Hi everyone, how are you? Just a few minutes, I will upload the PowerPoint here. Good afternoon, thank you. Hi. Yes. How are you? Hi, Kira. Yes, my file is converting now, so I'm waiting. This week we are gonna do matter properties and chemical and physical properties, and this changing, physical changing and chemical changing we will learn, and classification of matter we will learn, states of matter and measurement of matter. This is so important. SI units, maybe you heard that. The mass, the time, the temperature, the conversion of the temperature, for example, from Celsius to Kelvin or from Celsius to Fahrenheit. The last one, the density and percent composition we will learn, and they are using problem solving, and we are gonna do some example of these subjects, and I will give you some homework about that, but this homework only for your study. There is no any submitting day, because only for you to study. Okay, don't forget that. Some students ask me when do we submit this homework. You don't need to submit this homework, only studying this homework to prepare your midterm or final exam. That's it. I think it's clear. Still my file is converting. Yes. You said we still in physics. Can you? Okay. But your teachers all finished 2:30. I will start, and then you can listen later, because this is the recording, and you cannot catch, because you can listen this lesson again and again. Okay, let's start. Yes, here matters. Yes, matters, and it is properties and measurements. What is the matter? Do you know that matter is? What is that? What is that matter? Can you explain this term of the matter? Can you write the chat here? Can you explain that? What is the matter? Are you here? Yes, this is my. Yes, that's right, Emre. But in English, can you explain that? Not at all. You are welcome. Yes. What is the matter? How can you explain that? This term, because some subject has lots of terms. For example, the first subject. So you need to know these terms, and yes, everything that have size, shape, weight, yes, and then the volume, and then the mass they have, all of things is called the matter. Yes. Hi, thank you so much. We start the lessons. And dictionary definition of chemistry usually include the terms, for example, matter and composition and properties, as in the statement that chemistry, for example, is the science that's deal with the composition and properties of matter. In this and the next section, we will consider some basic ideas relating to these three terms. What are they? These are, check here, these are here matter, and what else? The second one, the compositions, and the other one, the properties. And better understanding of what chemistry is all about. For example, matter. Matter is anything, we can say, that occupies space. Yes, occupies space and displays the properties of mass and inertia, and they have some volumes and the mass and shape we can call this matter. And the other one, the second term is composition, and composition refers to the parts of components of a sample or matter and their relative proportions. For example, we can say water. Water has the 2 hydrogen and 1 oxygen elements, and they combine some proportion of them, and then they included some here. You say something. If there is a screen, I don't see it. All of you can see anything in the screen? I think you can. Yes, all of you, yes, can. Anas, you have some problem, I think. Can you solve that problem yourself? And the other one, properties. Which properties? The matter properties. What are these? For example, physical and chemical properties. And the properties are those qualities or attributes we can use to distinguish or one sample of matter from the others. And ordinary water, for example, for the composition term, ordinary water is made of, I said that, the 2 simpler substances, hydrogen and oxygen, and fixed proportion, we can say. For example, here let's look at picture. You can see here you can see some yellow and some brown matter. Can you say that about that? What are they? What do you think about that? For example, for the yellow, what are they? And what are these brown matter? Do you think? Minerals, copper, yes. Sadek, which one's copper? Yes, these are minerals, we can say, or we can say these are elements. The wire, yes, the wire is the copper wire, and then this solid one, the not unshaped solid one, what is that? And the and these balls, what are they? And that the yellow here, a yellow ball, and then this is the yellow again, but here some shape and this shape is differences between. and we can say this is the, what are they? What are you thinking? Maybe sodium. Sodium. Sodium we cannot hear like that because sodium generally must be in the ether solution, not like that here. Not sodium. Yes. What else? Think about that, please. This is the yellow. Which element color is yellow? Do you know that? Maybe you think that, yes, you think that the egg in the middle of the egg is the yellow, and this egg contains some sulfur element. So this is the color of yellow. Limestone. This is actually that one, the left one. The left one is the crumbles into a yellow powder when hammered, and these are the physical properties of sulfur, the yellow one, sulfur here, and the brown one, the copper. These are all of these physical properties. Okay, don't forget that. A lump of sulfur left crumbles into a yellow powder here when hammered. The right one, or the picture, this is the copper, can be obtained as larger lumps of native copper. Okay, this is the native copper, and formed into pellets, hammered into a tin foil, or drawn into a wire. Okay, don't forget that. For example, give me an example about the physical properties, the water. Okay, when liquid water freezes into solid water, this is the ice, and physical properties is changing. It certainly looks different, and in many ways it is different. Yet the water remains, for example, 10% hydrogen, 9% oxygen by mass, we can say. And while these water boiling, we have get some water vapor, and this is the vapor, but this contains only water molecule. That's it. The same thing, but the physical properties are changing. And the other one, the other properties is, what is that? This is the chemical properties. Chemical properties and chemical changes. We have a little the liquid one, and we have the bracelet, we can say, and here's some the medal here. What do you think? What happens here? What happens here? Can you say to me? What happened? I will give some hint for you. This is in it the zinc and gold here. Okay, there is a gold bracelet here. Just a minute. Yes, there's a bracelet here, gold bracelets, and here the zinc. Here, zinc plated nail here. You said chemical reaction. Yes, cleaning it from rust, we can say. Plating maybe, but we have here hydrochloric acids. Hydrochloric acids is non-color. Okay, this is the but here the yellow liquid here, because this is the chemical. There is a chemical reaction between zinc plated nail reacts with hydrochloric acid and producing some bubbles here. Can you see that there is some bubble? There are some bubbles here. This means the hydrogen gases, and you can see in on its surface, this nail surface, because the zinc and the hydrogen chloride reacts each other and give products the hydrogen bubbles, hydrogen vapor here. And the other one, the gold bristled here. The gold bristled is unaffected by hydrochloric acids, so there is no any hydrogen bubbles here. And in this photograph, the zinc plating has been consumed. Zinc plating has been consumed, exposing the underlying iron nail. The reaction of iron with hydrochloric acids imparts some color to the acid solution. So our acid solution become the yellow colored. Okay, this is we can say this reaction, the properties, chemical properties. Can you give me an example of chemical properties? The other example, can you give me? Yes, I am waiting. Can you give me an example? Iron rust, yes, here the iron rust we can say. Iron rust with the air, the oxygen, in the oxygen, yes, rusting. Yes, what else? But here, the reaction. But the rust, yes, there is a reaction. But here, the hydrochloric acids reacts with the iron. The rust, the iron reacts with the oxygen. It's cooking. Cooking. We can say cooking is chemical properties, chemical changing. Sugar being able to melt in water. No, this is the only physical, because there is no any changing in matter, chemical matters. Yes, is that a chemical property? No. Adele. Burning, yes, that's right. Burning is the chemical properties, chemical changes, because burning with the oxygen, for example, for the organic molecules, they give us some products. What are they? What are they? If we want to burn the organic compounds with oxygen, the organic compounds give us some products. What are they? Yes, that is, yes. What else? Yes, that's right, type. Thank you so much. Carbon dioxide and water, we can get these products. This is the important thing, because the organic compounds changing. How the chemical changing, the chemical properties of organic compounds changing. Okay, car engine, of course not. Car engine is the physical properties. Of course, Bihter. Okay, the other one is oxidation. Yes, oxidation is the chemical changes. Thank you. And the other one, this is the classification of matter. The IUPAC, can you heard that? Did you heard that? The IUPAC? Yes, this is the International Union of Pure and Applied Chemistry. Yes, this is the recognized 112 elements, and all matter is made up of just these types. And the non-elements range from common substances such as, for example, carbon, iron, silver, hydrogen, like that, to uncommon ones such as lutetium, thallium. These are generally unknown, but there is. Scientists have identified millions of different chemical compounds, and in some cases we can isolate a molecule of a compound. A molecule is the smallest entity having the same proportion of the constant atoms as does the compound as a whole. And here's the water molecule, and this is the hydrogen peroxide molecule. Only one oxygen has more than the water, and this is the gamma globulin. This is the general, we can call that the protein molecule here, and the matter is made up of very tiny units, and we can call that these are atoms, and each different type of atom is building block of a different chemical element. For example, the carbon element has lots of carbon atoms, or the helium element has lots of helium atoms contains. And the chemical compounds generally at least two elements or more elements joined together and get the compounds. Here the compounds, we can say only the hydrogen and the oxygen, the atom or element, we can call. And other one, this picture. Actually, these pictures, we have some mixture. Do you know that this is the homogeneous or heterogeneous mixture? What are they? Do you know that? I think you know. Only say about that. Yes, what is that? Homogeneous and heterogeneous mixture. What are they? This is the pure or not pure. Do you know that? Want to say something? Because of course you know that. Of course, because of your high school, all teachers said about this homogeneous mixture and heterogeneous mixture. Yes, I'm waiting. Homogeneous is mixing stuff and become like one thing, sugar and water. Yes, thank you, Nada. And what is the differences? Yes, what is the difference of these homogeneous and heterogeneous? Heterogeneous mixture have different stuff in them. Yes, that's right. Nasar, give me an example about the heterogeneous mixture. I think you can. Yes, homogeneous. Nada, give an example, sugar and water. Yes, if you put this sugar in the water and mix in it, and there is no any sugar, and you cannot see any sugar in the water. This is the only one phase. This is the only one phase, but this is the mixture one. But this that means we can call that if there is no any phases, the different phases, this is only one phase, we can call that the homogeneous mixture. But we can call this mixture two or three stuff, or the compound or matter or the phase, we can call that this is the heterogeneous mixture. Yes, heterogeneous mixture is oil and water. Thank you, Emre. Nada, but heterogeneous is the total opposite. They don't become the same thing and like sand and water. Yes, that's right. And Mohammed, we can, we said something, you said something different. Okay, you ask me your question after the lesson. Sand and water, this is the heterogeneous mixture. Oil and water, yes, this is the heterogeneous. So stuff that cannot get mixed together are heterogeneous. Yes, we can say, for example, air. Air is homogeneous or heterogeneous mixture or pure matter. Air. Air, what is that? Air is, what is that? Air is the pure matter or the mixture. What is that? This is the homogeneous or heterogeneous. Air is homogeneous. Homogeneous, yes. What else? All of things the same. Air is heterogeneous, Bihter. Why, Bihter? You agree? Which one? Heterogeneous or homogeneous, Emre? Why? Yes. Why? Bihter, you said heterogeneous. Why heterogeneous? Use while when you see the air, you see only one color, actually, one phase. So you cannot explain in English. You can explain in Turkish. I can understand, okay? You write here. Actually, the air is homogeneous mixture because this is the mixture because there are lots of gases. It has the nitrogen, the helium, the carbon dioxide, and this is the sulfur dioxide, like that. Lots of gases. But when we see the air, this is only one phase. This is only one color. Okay, so we can say that this is the homogeneous mixture. For example, the copper 2 sulfate put in the water and mixed, there is a blue solution we have. This is the homogeneous mixture we can call like that. Yes, Bihter, you remember wrong. Yes, ordinary air is homogeneous mixture, and this has several gases, elements, nitrogen and oxygen. Seawater is a solution of the compound water, and sodium chloride and a host of others. For example, gasoline is a homogeneous mixture or solution, we can say. These compounds, this picture here, this picture, is that picture homogeneous or heterogeneous? What do you think? Carbon dioxide is homo mixture. Carbon dioxide only the gas, and this is not the mixture. This is only pure carbon dioxide. Okay, this is not mixture. Heterogeneous. This picture hetero. Yes, yes. Actually, you see some bubble here or some ball here and the colors. Actually, when we throw a microscope, homogeneous milk here, homogeneous milk. Actually, while you see this milk, this is only white color. This is only one phase you can see. So you can think that this is the homogeneous mixture, I think. But while you seeing this solution of milk, this is some globules of fat here in the water medium. Homogeneous milk is a heterogeneous mixture, actually. Okay? Is that clear? I think clear. Just a minute. Just. Can you hear me? Can you hear me? No? Okay. I think my connection is gone. Okay. Yes. Please, you don't write your language type. Okay? Yes. Yes, homogeneous milk is heterogeneous mixture. Don't forget that. Here, this scala is important actually. Every sample or matter is either a single substances. We can call that this an element or compound, or a mixture of substances. At the molecule level, an element consists of atoms or a single type, and a compound consists of two or more different types of atoms, usually joined into molecules. For example, look at here, the chart. This is the all matter. If these matters can be separated by physical means, that means the mixture. Okay, don't forget that. And the mixture is uniform truth. Is that the yes, this is the homogeneous, but this answer is the not, this is the heterogeneous one. And our matters can be separated by physical means, cannot be separated by physical means. This is the substances, okay? And substances maybe sometimes can be decomposed by chemical process. If that's right, yes, this is the compound one. Okay, for example, the water, by the electrolysis we can get the hydrogen atom and oxygen atom. Okay, and the other one, the substances cannot be decomposed by chemical processes. This is the element, because the atoms cannot separate their tiny matter, we can call it. Decompose mean this is the separated, we can say. Okay. Yes. Okay, then. Here, stays all matter. There is a water here, the eyes of the water. Eyes shape of the water. Here the vapor, and there's lots of water molecule, and the ice molecules arranged like that, and the water molecules arranged like that. When the water molecules arranged in the solid one, the volume is larger because of the hydrogen, and this is type. While this melting with the liquid one, these molecules become closer. Okay, become closer here like that. And the vapor, in the vapor, these water molecules getting larger distances. Okay, don't forget that. This is the state of matter in a solid atoms or molecules are close contact. Okay, don't forget that. And we can call this crystal and highly organized arrangement. A solid has a definite shape. Okay, definite shape. In a liquid one, the liquid phases, the atoms or molecules are usually separated. Okay, greater distances than in a solid. In the gases one, the gas phase, distances between atoms or molecules are much greater. And this picture shows a block of ice, heated surface, and three states of water here. This circular insets show how chemists conceive of these states microscopically in terms of molecule with two hydrogen atoms here, the white one, and red one, the oxygen. This is the A, ice one, the molecule are engaged regularly. And the liquid, the B1 here, the molecule are rather closely, but move freely. And the C1 here, actually there is a C, in gases, water, the molecules are widely separated. This is the state of matter. And measurement of matter is so important for the chemistry or chemical reactants and chemicals. So important because while calculating our problems, we can always use these measurements units, SI units. For example, physical quantity. This is the length. Length unit is meter, and the symbol is only m. Okay, don't forget that. The mass very important for us because always we use that this mass, and mass unit generally kilogram, and the symbol kg. But our laboratory always we use that the gram one. Okay, because while we get the products, only the small quantity we get, so we use that the gram one. Okay, in the industrial products they can use the kilogram. Yes, there is a time unit is the second, and the symbol is S, and generally the time we will use in the chemical kinetics. And the temperature, generally Kelvin the unit, sometimes the Celsius, but generally in the gases or the other subjects we will use the Kelvin, so we have to convert that the Celsius from the Celsius to Kelvin. And the symbol is the key. And amount of the substances, this is very important for chemistry. This is the mole units, and the symbol is the mole. There's no any E. The differences between unit and symbol. And electric current, ampere and A, luminous intensity, candle and CD. The last two one we don't use that in physics. Maybe you can use, but these SI based quantities very important. The mass, temperature, amount of the substances, especially very important for chemistry and our problems. And generally we express the measurements as the products and numbered units. Always we will use here the mass. The mass, here we have the symbol here. That symbol means proportional to. Okay, this is the mass, this is the weight, proportional each other. It can be replaced by an equal sign and a proportionality constant. We can say this is the weight, this is the unit gram. Just Yes, here the weight, the mass describe the quantity of the matter in an object, and uh, in SI the standard of mass 1 kilogram, for example. Gravity is important, Adel. Okay, weight has the gravity and the mass only mass, we can say. The 1 kilogram, which is a fairly large unit for most application in chemistry, the more commonly we use that the unit, the gram. Okay, don't forget that symbol is only G. Okay, don't forget that. Weight is the force of gravity of, on an object. Okay, if you read here, you can understand, and it is directly proportional to mass. Here, like that, this is the weight one, and this is the gravity, and this is the mass. And the other one, the time. The time generally use the chemical kinetics. We use that, for example, if we want to produce a product, we use sometimes, for example, seconds, minutes, hour, year, week, or a month we can use, and the time is actually important for the chemical reactions. The temperature also important because we use that this temperature in the gases generally, and in the problem they give us the Celsius degree, but we have to convert that from Celsius to Kelvin, so you have to know the conversion differences, conversion relating between the Kelvin, Celsius, and Fahrenheit. A comparison of temperature scales here for the A, the melting point MP, we can say, of the ice here, and the B, the boiling point of the water here, and 0 Celsius degree, 32 Fahrenheit we can call. Also we have some formula have, and the interval on the Kelvin scale called a Kelvin is the same size as the Celsius degree, we can say. And when writing the Kelvin temperature, we don't use any a degree, only key we write here. For example, we write 0 key or 300 key, not 0 degree key. Okay, degree, there is no degree for the Kelvin, don't forget that. The Kelvin scale is an absolute temperature scale, don't forget that. There are no negative Kelvin temperature. Okay, don't forget these terms. Here, Kelvin from Celsius or Fahrenheit from Celsius, Celsius from Fahrenheit. If you know one of them, you can find easily the other term of temperature. For example, if you know that the Celsius degree, you put that value here, and then you can find easily the Kelvin. Or if you know this Celsius degree, you can find easily that Fahrenheit. Okay, don't forget that. For example, they ask you or they give you the Fahrenheit temperature, and you will find the Celsius degree. First of all, you have to put this Fahrenheit temperature, and you can find this Celsius. And then if they ask you to Kelvin from the Fahrenheit, if you find this Celsius and then put here that value, and then you can find this Kelvin easily. Okay, don't forget that equation. Okay, don't forget that, because this is important for the other subjects. For example, doing an example of that, they ask us the predicted high temperature for New Delhi on a given day is 41 Celsius degree. There's a degree, must be. Is this temperature higher or lower than the predicted daytime high of 103 Fahrenheit for the same day in Phoenix, Arizona, reported by a newscaster? First of all, they give us Celsius degree. They ask us the Fahrenheit one actually. So you have to convert that from Celsius to Fahrenheit. So you know that this conversion about the temperature, you should know that, you need to know that. So this is the 9 divided 5 multiply with the Celsius degree, and then summary this, collect this 32 volume. You put here the 41 here, 41 Celsius degree volume, put here, and then calculate. That's it. And you will use, you will find that Fahrenheit, the predicted temperature for here, the predicted Fahrenheit here, the temperature here, only 3 Fahrenheit higher than for Phoenix. That's it. Because these units should be the same. If you want to compare these temperatures, the temperature units need to be the same. Okay, need to be the same. I think you understand. Do you understand that? I think I understand. I pass it. Okay. Yes, this is your homework. I explained by the starting the lessons. This is only for you. Okay. Anas, not the last part. The last part, they given. It is given that Fahrenheit. This is the predicted daytime high of that one. This is the Fahrenheit, and you will find, you have to need here to find the Fahrenheit. So you have to convert that from Celsius to Fahrenheit, and then the differences between these predicted and that temperature. Only 3 Fahrenheit higher than for Phoenix here. Okay. I think, okay. This is your homework. This is only for you, for your study. Okay. Density and percent composition, they are used in problems. Adele, please, the beginning of the lesson, I explained all of that homework, okay? There is no any submit. Density formula here, density formula, D is equal MV. All of that, you have to know that these units, these terms, what is that? This is the mass, this is the volume, and this is the density, okay? The mass generally units, the gram, and the volume units generally will be milliliter, okay? Milliliter, sorry, milliliter. And so the units of the density, gram divided milliliter. Don't forget that, okay? Don't forget that, because this is the conversion about, for example, generally we cannot measure liquid with the gram units. Always milliliter important for the liquid one, liquid measurement. That means the 1 milliliter is equal 1 gram, like that, okay? Don't forget that. And that conversion are conversions are important also. For example, 1 centimeter cube is equal 1 milliliter, and 1 milliliter is equal, that means the 1000 centimeter cube, and that means the 1 liter, and this is the 1 decimeter cube. Okay, don't forget that. For the solid densities, from about, generally we can quote here like that, for the solids 1 centimeter cube, because for the solid matters, while calculate it is volume, we have to use the centimeter. Okay, so the units will be like the centimeter cube. And the liquid densities, always liquid densities or liquid volumes, use the milliliter or liter. Okay, and the gases, mostly in range of a few gram per liter, we can call it. You will see the others subjects, the next subjects, you will see that the gas densities. For that, the liquid and solid densities are very important. Yes. And look at these examples. Yes, the stainless steel, here the stainless steel in the solid cylindrical rod pictured below here, yes, below here, has a density like that. This is because of this centimeter cube, because this is the solid one. Okay, don't forget that. If you want a 1 kilogram mass of these rods, how long a section must we cut off? Okay, you have to calculate that the volume of cylinder, and you know that first of all you have to calculate this solid one volume. You know that here the density, you know that 7.75 gram divided centimeter cube, and you know that they ask us 1 kilogram mass of this rod. If we want a 1 kilogram, you have to convert that gram to gram, because this is the only gram. You know that you need to know that the density always use the gram unit, okay, not kilogram unit. So you have to convert that. The mass will be 1000 gram. Okay, you know that you need to know that this formula, or you can say 1 centimeter cube is equal 7.75 gram. 1000 gram, how much centimeter cube? Okay, if you want to use this formula, or you want if you want use the proportion, it's up to you. Okay, here 1000 gram divided that, because this is vice versa. Yes, here you will use that 1 centimeter cube. Okay, this is the volume. Okay, this is the volume. And the cylinder, the cylindrical rod, here the cylindrical rod, you have to know that from the maths, because the cylindrical volume, how can you find this cylindrical volume? This is that one. The higher and the P2, you have to put all of that. Okay, and you know that from the density, and you will use that the section of how long you have to cut off. Okay, you don't forget that. This is the inch one. There is some stranger, what is that, value from the maths. Okay, don't forget it. This is only this is only maths information about the solid cylindrical. Only you will find this volume by using chemical information. Wish that where did you get VP? What is that? This is I said to you, this is only cylindrical, solid cylindrical volume. Okay, this is maths information. This is okay, maths. Yes, I passed that one. Okay, this is your homework. Again, here the density of trichloroethylene, the liquid one, and you will use for the B example here, you will use the same cylindrical rod, okay? You will use for the B. And that's it. Yes, percent composition as a conversion factor. Percent is the number of parts of a constituent in 100 parts of the whole. To say that a seawater, for example, contains 3.5% sodium chloride by mass means that there are 3.5 grams of sodium chloride in every 100 of seawater. Don't forget that. That means the same. 3.5 grams sodium chloride. That means only 100 grams seawater. Don't forget that. Yes, we have some example. Yes. 75 gram sample of sodium chloride, this is the stable salt, is to be produced by evaporating to dryness a quantity of seawater containing 3.5% sodium chloride by mass. What volume of seawater in liters, don't forget that this is the liters, must be taken for the purpose, and they have to give us this seawater density. Here, this seawater density here. Approximately, we can call that only one, the density of the water. We can call it here. This sodium chloride water, so actually seawater, is the mixture or not mixture, or which one mixture? Homogeneous or heterogeneous? Yes. I am waiting an answer. Yes, I am waiting. Homogeneous. Yes. Yes, homogeneous mixture, and I want to get 75 gram of the salt. How can find this salt? How can you get this salt? This is 75 gram sample sodium chloride. Actually writing here by evaporating, okay? By evaporating to dryness with that mixture, you can get this salt, and the water vapor is going, and then you can get only salt. Heating, yes, heating or evaporating, we can call it. Actually, here the percent, we can say here 3.5%. What does it mean? This is 100 gram has seawater, for the seawater, 3.5 gram sodium chloride. Okay, they want 75 gram. 75 grams sodium chloride they want. Okay, how can yes, what volume of seawater, I get, and then what is that? This is the proportion actually. Points, yes. What is that? This is the 2142.85 gram. Okay, this is the gram, but they ask us for the liters. Okay, you have to convert it. How can you convert that? How can you convert these gram from gram to liter? Which terms you will use? With the density. Thank you so much, Nada. Because the density is, sorry, I can't write. Yes, the density is gram divided milliliter means, and they given here milliliter. What is that? What does it mean? This is the 1 milliliter. 1 milliliter seawater is equal 1.03 gram. Okay, but here that gram here, the same units written the up down. Okay, this is 2142.85 gram. How many milliliters we have? This is the actually 2080 point. Sorry, this is the 0.44 milliliters. This is the milliliters. They wanted liters. You have to convert that, and you have to divide it 1000, and that means the 2.08 liters, and is approximately, if you want to approximately, that means this is the 2.1 liters. Okay, I think it is clear. Only this is the conversion. Actually, generally, I will use this proportion, not the formula, because this is easier than to use this formula for proportion. Is it clear? Yes. Okay. This is your homework. How many kilograms? They ask the kilograms, but you will use these liters, and always conversion you will use. And the last slide, significant figures. This is not so important, but generally they learned from the maths here. Significant figures, for example, two significant here. Two significant figures, that means the 7.5, and if you want to three significant figures, here the 7.50, like that, and this is the four significant figures. That's it. And yes, there is no any, yes, there is no any more for today. That's it. If you have any question, you can ask, and then you can go. Is that good lesson? Yes, I am waiting your comment. Okay. Is there any question? Thank you so much. See you next week. I have a physics lecture. Ahmet, please listen to my first recording, okay? Always our lessons will start 2:30. Ahmet, actually, our lesson 2:30, okay? You don't, Nada, you don't understand this slide. This is only significant figures here, okay? That means, for example, if you multiply with the 10, beginning of that figures will be only 2 numbers. Here the 3 numbers, this is the significant figures, and this is the 4 significant figures. That's it. Okay. See you next week. Take care of yourself.